or by angles.
Okay.
It's hard for me not to draw, analogies to real life like dating, but you look, we all look at things certain ways. You either look at a triangle by its sides or by its angles. There is a little bit of overlap. Um, if all the sides are the same and all the angles are the same, do you remember what that is called? And I'm writing it down now.
Equilateral.
Equilateral. And one implies the other. So it's like if all the sides are congruent, then all the angles are congruent. If all the angles are congruent, then all the sides are congruent.
Okay.
And that's what I mean by vocabulary. Like you have to know this.
Yeah.
Uh, if two sides are congruent, this symbol means congruent. Have you seen that before?
Yeah. Yeah.
Okay. And that means that two angles are congruent. This is isosceles.
Okay.
All right. If
This.
if no sides are congruent, then no angles are congruent. This is called scalene.
Scalene is when no angles are congruent.
And no sides are congruent. So all different sides, all different angles.
Okay, let me get that down.
So three of those that you have to know, just, you know, like, you know, I don't know. You know, so I can't do that. I got to be careful.
What's the second one? Isosceles?
Isosceles. It's in your
Isosceles.
book there. You can. It's the
Yeah,
ISOSCELE. That's
gotcha. Okay, I got it.
all right. The next thing here is if the angle is, and there's three of these that we can talk about. If the angle is, and we'll start with either one. Start with the easy one. If there's a 90-degree angle, it's called a right triangle. But it can be modified, or it's like this is an adjective to what it could be, and it could be a right isosceles
Yeah,
triangle. Okay, that's possibility. If if all angles are less than 90, this is called an acute triangle.
okay.
If one angle is greater than 90, it's called an obtuse triangle.
All right.
All this vocabulary to do, 1 through 4. So really keep in mind,
Angles
it's
less
very
than
heavy.
90 or acute, right?
Yes,
That's
but all the angles have to be less than 90.
yeah.
If there's one 90-degree angle, it's a right triangle. If one angle is greater than 90, it's obtuse. So all of this is needed to answer 1 through 4. So we're going to look at that. We're actually just going to look at A, B, C, and D. So we'll look at these one at a time here. So A is a right triangle because it has a right angle.
Okay.
Now, what's odd or maybe unclear is that all three sides are different in length.
Hmm.
You see that visually? Kind
Yeah.
of, does that?
Yeah.
Okay. That means it could be a scalene triangle because no sides are congruent, no angles are congruent.
Okay.
You generally don't write the word like right scalene triangle. You just write
Yeah.
right triangle, but
Okay.
I don't know, it could be there. Let's look at B. B has two sides congruent.
Hmm.
So two sides congruent is an isosceles triangle.
All right.
Do you see any right angles in this
Yeah.
one?
Yeah.
Okay, so when I say, and I didn't make this clear, this little red box here, This is the right angle.
Oh, no.
That's that
Yeah,
means
sorry.
right angle. So if you don't
It's like
see
the
that,
90 degrees angle.
yeah, if you don't see that, there's no 90-degree angle. So that it's just isosceles. Okay. But C has a 90-degree angle in it.
Yeah,
You agree with that? You see that
yeah.
there? So it's a right triangle, but maybe it's a bit more. Okay, and
Yeah.
what do I mean by that? Well, maybe it's right isosceles because see how there's two sides that are congruent?
Mm-hmm.
So that makes this a right isosceles triangle.
Yeah.
Is that okay?
Yeah.
Cool. So the next thing here is D. Tell me what you notice about D. Give me some words here, please.
All the lines are equivalent, like they're all the same
Yeah,
length.
all sides. Yeah, all sides are
Both
congruent.
sides are. And it's
So
triangle.
so which
Equal
so
or
what does that mean?
lateral.
It's
Equilateral.
equilateral.
Yeah.
Yeah, equilateral triangle. The notation here in E is that all the sides are different.
Mm-hmm.
All sides different.
But okay.
What would the best name for that be if all the sides are different? That's when no sides are
Scalene.
congruent. Scalene,
Scalene.
yeah, scalene, whatever. I don't get into that. Scalene triangle. Good.
Yeah.
Uh, okay. Do you have problems in here you have to complete for homework?
No. No. Just going over it.
Okay.
Did I send over the one that's has the questions, like draw lines? Let me see. Yeah, like acute triangle ACT with AC equals CT, like those things.
Yeah, we can do some of those next.
Okay, cool.
So there's two style of questions that you'll get in geometry. The first is the where you're given a picture. You like those. The second one is where you are not given a picture, which is this one here.
Okay.
And that's the much harder time type. So you'd have to draw a triangle. So draw a triangle. Now, this is an acute triangle because all the angles are less than 90. You have to kind of um,
Yeah.
um, fortunately, so like you have to know how to draw some of these. Um, this is acute. Let me give you an idea of what an obtuse might look like. This one's obtuse. This angle here in the lower left is more than 90.
Yeah. Yeah.
Okay.
Would that be like 70 or no?
When you say 70, more than 90, I don't know, be
Oh, it's like
110
100,
degrees.
110.
Yeah,
Yeah.
degrees. Yeah.
Okay.
But you kind of have to have a good sense of how to draw an acute and an obtuse. Okay. Now,
Okay.
um, I don't know if your teacher wants you to make these look correct, but if you just label it ACT, AC is there and CT is there and you're done.
Mm-hmm.
Um, but it doesn't really look like they're the same. They don't look congruent.
Mm-hmm.
That might be a question for you to ask your teacher or something to say. It's like, hey, like if the drawing does it need to look to scale? You know,
I
that's
don't,
kind of what
I
you're
think it's
asking.
just if you put the lines there to like show that you want those to be like, even though it's like not the same length, that's all that really matters.
Okay.
You know what I
It's
mean? It's
like
like, yeah.
it's are you guys using a ruler? Do you have a
No, we're
protractor, a
not. We're
compass?
just sketching it. Like it doesn't really matter, honestly. I don't think it's just like as long as you can show like you're trying to put that there. I don't think it has to be
Okay.
exact yet, but recently we haven't used rulers or anything like that. So
Yeah.
yeah.
Um, so let's see here. That then there's a lot of ways, like there's a lot of answers here. Like here is one that's also correct.
Yeah.
Like the teacher will look at it and say, oh yeah, that works. Um, number six. Actually, I need to zoom in. Can't get any of here. Scalene triangle SCL with angle bisector CM. So scalene, what does that mean in this case?
Um, so no sides are congruent.
That's right.
Yeah.
So there's a lot of like this one is scalene
Yeah.
and this one is scalene. Like there's a lot of possibilities. So just
Probably the
some
easiest triangle to draw, huh?
yes, yes.
Yeah.
And you don't even have to like make like you can just draw the same one over and over again for the
Yeah,
most part.
yeah,
So SCL, that is important. There's kind of this mapping of like the direction. It's like, okay, S to C to L back around.
yeah.
All right. So in this case, it's like, well, make sure your letters are in the right order. Like, don't, it doesn't really matter, but for this, but it will in future problems when there's more letters. Just make sure they're kind of in an order here. Now,
Yeah.
angle bisector CM, it's telling you it starts at C. It starts at C, and M is got to be on the opposite because the only place it can go where it connects on the triangles over here without curving. Like it can't curve, things like that.
Hmm.
And any idea what an angle bisector is?
Um, I do. I've been hearing that, but like I don't exactly know.
What about a bisector or something bisects something?
I'm not completely sure. Like it gets in the middle of it.
Yes, cuts in half.
Yeah. Okay.
So it cuts the angle in half. So this angle right here is congruent to this angle right here.
Yeah.
Okay, now angle bisector is another word that you have to know the definition of. So at the end of this unit or chapter, I don't even know what to call it. You call it units in your school, units.
Yeah. Yeah. Yeah.
The end of unit one, your review will have like a list of 20 or 30 terms, and you have to know all of them.
Okay.
And this is another one to know.
Okay.
It's really important that you know them to be able to do well.
Okay. Yeah. I was hearing that a lot. I've been hearing that a lot in class, but like I'm not like 100% sure, but I knew something in half. Cut
Okay.
it in half.
That's
Yeah.
enough. That's enough. I cannot help you memorize these. You can only do that on your own.
Yeah. Okay.
All right. Now, do these angles look congruent to you just visually?
Yeah, they do visually, I guess.
Okay. I mean, I don't feel like I did a great job, but I feel like I did an okay job. Now, let's just say this is SCL over here. And let's say I put M right there. Do these angles look congruent to you?
Yeah.
We're talking about
Oh no, 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 they're not congruent. Sorry. Sorry.
they don't look very congruent. So you have to be really, there's some reasonableness, right?
Mm-hmm.
You and your sandwich, so you're and a friend's split a sandwich. Yeah, I guess we don't do that anymore, but you cut something in half, slice of pizza in half, last slice, like where it's kind
Yeah.
of in the middle.
Uh-huh.
So just be reasonable with it.
Okay.
All right, let's look at this right here. Number 7. All right, isosceles right triangle. So you got to start with a right triangle, which means you have to put that little box in there. The little box means it is a right triangle.
Yeah.
Okay. So VAR means those letters are going here, and you can't just put them arbitrarily because it says the measure of angle C R to A is 90. So the middle letter is the vertex.
Okay.
Have you seen or heard that before in class?
Yeah. Yeah.
All right. Now that means R goes right there. And that means you have to label this in such a way where the progression is C to A to R if there's like a so
Mhm.
for example, C to A to R would be okay. But you could also put C up here, A down here, and R down here. That would also be okay.
Okay.
Now, just looking at this, have I shown that it's isosceles? Have I shown that two sides are the same?
No, but I kind of just figured that because of yeah.
So we do have to label, and it has to be the legs.
Okay.
And if you're wondering like why they're called the legs, I think if you were to make it maybe upside down, maybe this kind of looks like a leg and a leg coming out from the middle. I don't know for
Yeah.
sure, but that's what it is.
Okay.
All right. Let's look at problem like 12.
Okay.
That's not what I want. Are you taking chemistry this year?
I'm taking physical science.
Physical science. Okay. All right. So here we go. Here's the graph for number 12.
Okay.
It says, the question says, and we'll snip that in as well. It says locate a point L. Basically, it's saying put a point L on the graph so that you create a triangle, and the triangle is an isosceles triangle. This time you have to be more exact. Like you can't just like arbitrarily pick.
Yeah.
Like let's say I put this point there. Does this make an isosceles triangle?
Yeah.
So if it does, then which two sides are congruent? And you can't just label them this time.
Oh, actually, yeah. Wait, no, it wouldn't. Never mind. I was not looking at the right
Yeah,
thing.
it does not. Okay. But if I make
I
something like
misread it. Yeah.
this, does this now look like an isosceles triangle?
Yeah. Yeah.
It does. Let me put L there. This side is congruent to this side. Let me draw another one here. Let's say I put it right there. Does this triangle look like an isosceles triangle now?
Yes.
It does. Okay. So the truth here, the answer is that any point L along this line would actually do it,
Okay.
believe it or not. So again, there's a lot of possible answers there. Okay, we got a couple more minutes here, so we'll do a couple more problems. We'll look at 13. Hopefully this is helping. Uh, again, a lot of definitions, a lot of definitions. All right, locate a point O so that triangle MOE is an isosceles right triangle. Okay, so that right is a big deal.
Okay.
So it could be, for example, that this is the triangle and this is a right angle. You agree with that? See how that's a right angle?
Yeah.
But what would make it isosceles? What is the requirement for isosceles?
For two of the lines to be the same length.
Two of the legs in this
Leg.
case have to be the same. So from E to M, can you count from E to M for me, please?
Yeah. 7.
And then if is M to O also 7?
Um. Yeah. Actually.
Yes. Okay. So that means that means that this does work. But if you move O anywhere else, like let's say you put it, here, would that be isosceles now?
No.
No, it would not, because it would be a right triangle, but it wouldn't be an isosceles.
Yeah. Yeah.
And that's the challenge here. Now, I can also do the following here. Whoa, going in the wrong direction here. I could also go down here from E. Is this a right triangle?
Yeah.
It is. Now, is it isosceles?
No. Wait. Yeah. Yeah.
It is for the same reason. So there's more than one answer is the point. And when you're drawing stuff, there's more than one way to make it look look correct.
Okay.
All right. So go ahead and stop here for